All right. Good afternoon. Welcome. Thank you for taking your time joining this session on maximizing Windows 7 performance. A session that will give you insight into what Microsoft have done to increase the performance in Windows 7 and the tools and techniques that we can use to troubleshoot when we have performance-related issues. My name is Johan. I will be your host for the next 75 minutes. I'm a config manager MVP, and I've been an IT guy since I was about 10. I've been working now in the industry for 20-some years, and I normally work with OS deployment as my focus area, but of course, an OS without drivers, apps, things that run on top of it, it's quite dull. It's quite boring. So you do run into issues if you work as an IT pro related to running apps on side OS, and that's what we're going to talk about in this session. Now, performance for the end user is critical. I mean, we don't like when the system or machine we are using is not performing the way we expect it to do. We don't like when we are trying to play a game and it's stalling. We don't like when we try to do some office work and it simply don't respond the way we think it should work. And back in the XP days, quite frankly, we didn't have many tools that could help us do live analysis of the systems that we were running. Sure, we can kick off perfmon, but that's about it. And in the Vista timeframe, Microsoft actually started to build into the platform a foundation to be able to do performance-related troubleshooting. And they actually put up a new web page, the performance team at Microsoft. It's called Pigs Can Fly. It's their own web page for the performance toolkit team at that time. How many of you liked the performance of Windows Vista? Not too many, right? But here's the thing. The major reason why Vista was so slow, at least in the beginning, was due to drivers. The main reason was drivers. Microsoft changed the driver model. Vendors were trying to learn to write new driver for Windows Vista, and they failed miserably for most times. So that's why we could see that in Service Pack 1, in Service Pack 2, and also as long as the vendors actually learned to write drivers, it actually got a little bit better. And then Microsoft did the final tweaks into the Windows 7 release, and suddenly we have a platform where we have vendors writing correct drivers, and we have a base OS, and that is actually why Windows 7 is quite performant today. Now, it's all about expectations. You should not really, or I should not really, expect that a 6-year-old laptop will run Windows 7 lightning fast compared with maybe running XP on the same machine, because it's simply a bigger OS, there is more stuff going on. But what you can do, and I actually met the customer 2 weeks ago in Orlando who did the smartest thing I've ever heard a company can do. They went to Fry's and ordered solid-state drives for every machine in their environment. They ordered 128 gigs for their laptops and 160 gigs for their desktops. And suddenly, a 3-year-old laptop they had were running in circles compared with a brand new laptop running a non-SSD disk. That's how much you gain from running SSDs on a machine. I also brought a demo machine with me today. I'm running Server 2012 on top of it. I have about 1.2 terabyte of disks, which is not extreme, but these are solid-state drives. So you get quite the performance on a laptop. I'm running Hyper-V. I have a bunch of VMs running that will be used through the demos. I'm able to run easily, because I have 16 gigs of RAM in this laptop. I can easily run 10 VMs at the same time on an airplane for about 15 minutes. And I'm also using a feature in Server 2012 called data deduplication. I used to call that the carrot effect. I'm not kidding. This is a feature you enable on the file system for Server 2012. And when you do that, you cannot do it on your boot volume, but you can do it on your data volumes. It will do this to your files. It will simply take all the files that you have and hack them into pieces, small chunks. And every piece of the carrot that looks the same is thrown away. This is something you can get from high-end SAN systems, like in IBM 7000. You can get it in hardware. Now you have it in software inside Windows. So if I view properties on one of my drives, I ask you to pay attention to size and size on disk. This is because many of the files have similar chunks in it. This is not something you should run on production live running VMs, but for archives, ISO image stores, superior. You can have terabytes and terabytes of storage on a single volume. The record I've seen so far was one system having a half terabyte drive with 10 terabytes of content on it. I thought that was quite impressive. All right. Anyway, inside Windows, we have tools that can help us do troubleshooting. We have tools that are sort of inbox, but they are very related to the inbox tools. They come from sysinternals, and they, of course, are now Microsoft. And we also have the performance toolkit that we will spend some great time with today, which is part of the SDK, and you can download and use that for your machine. So it's not for developers only, it's for IT pros as well. This session is related to IT pros, what we can do to troubleshoot system. Now, if we have a system that doesn't respond correctly, we or the end users will have sad luck on our face. We simply expect the system to be responsive. Now, in OS, when you run it, there are many shared components working together, and it often takes only one of them to break the system and give that non-responsiveness back to us. And for the most part in Windows 7, as I said before, it's the disk. Most of you have realized that running Windows 7 with half gig of memory, it's a bad idea. So most customers who are doing Windows 7 deployment projects, they raise the bar. The least amount I've heard about is 2 gigs, but I know many customers, they raise the bar to 4 gigs for every machine supposed to run Windows 7. But if you have between 2 and 4 gigs, you normally don't have issues related to memory. If you have performance issues on those machines, yeah, it's the disk. And it only takes one bad application that is trashing the file system that all other parts of the system will simply be unresponsive as well. So we need to be aware of that the resources are limited, they are shared, and it's only take one bad application or a service or a driver that will make the performance really, really bad. Now, in Windows 7, Windows 7 is really good at lying to you. If you're copying a file from one folder to another on a drive, it goes pretty quick, and it finishes, but it's not really finished. Just because the dialog box goes away, it doesn't mean it's finished, but you believe it's finished, because it's simply copied to buffers in RAM, and while you start to do other stuff, in the background, that information is still being cached and write to the disk, or written to the disk. So we have a defined new caching model in Windows 7 compared with Vista. We have more buffers, they are bigger, so it appears to be more responsive, even though it may not actually be done what it's doing. The networking stack in Windows 7 is drastically improved compared with Windows Vista. You can see network cards being able to offload components. We see video cards being able to offload work that normally the CPU would do. So if you have a nice network card in your, graphics card in your laptop, you can actually offload stuff to that as well. You will see a great improvement in startup, shutdown, and resume times. But this is also one of the most problematic areas to troubleshoot. I mean, how many in here had a user asking, why does it take so long time to log in? A good few of you. How do we troubleshoot it? Well, it's difficult because the normal tools that we use, well, we can't really start them until we can log in. And, well, that's the problem. So it's a sort of a catch-22. But luckily, there are now tools that allow us to monitor the entire startup process and the entire login process, even hibernate and resume, so we can figure out what's going on. You will see that in the event viewer, you will now get events related to performance. And it will actually, and I will demonstrate this to you, you will see, for example, what device driver that was preventing a machine from going into shutdown or hibernation. Do you remember back in the XP days, you tried to shut it down and sometimes it just didn't? Really difficult to troubleshoot. Now we have the tools to troubleshoot it. Now, in Windows 7, and this is my personal view of things, there is a feature called Ready Boost, which allows you to inject a really fast USB device or a USB drive to the machine so that Windows can use that as memory, as a cache. If you have so little memory that you can make a benefit of using a USB drive, you should not be running Windows 7 on that machine. Period. Add more memory. Don't fiddle around with external USB sticks to get the same result. Same with Superfetch. Do we need Superfetch, which is basically preloading apps into memory to save some time, if we have solid-state drives? No, we don't. You can just disable that service or disable that feature. Do we need to run a defrag on machines with solid-state drives? Absolutely not. Luckily, Windows 7 normally detects that when you deploy it and disables it. But sometimes if you, for example, do a backup and restore to a new drive, it doesn't do that. So you have to go in and disable that, schedule tasks manually, or even you could, of course, also disable the service if you need to, but it's enough to do the scheduled task. In fact, defragging a solid-state drive will only do one thing for you. It will tear the drive. That's the only thing it will do. Now, we also have encryption. Often we do encryption, we do BitLocker on Windows 7, especially on laptops. And without solid-state drives, the user will actually feel that impact. They can actually notice if they compare a system that wasn't encrypted before and that is encrypted now. Should you run defrag on a BitLocker encrypted system? Well, if it's SSD, no, still. If it's not SSD, yes, because BitLocker is still doing sector-based encryption. And it still suffers if an application is jumping back and forth across the drive to get files that it's going to use. So yes, it's still needed if you don't have SSDs. Now, when you boot Windows 7, you immediately notice that if you had Vista on that machine before, it's much quicker. And that's because Microsoft changed the way it loads drivers. You will actually see in the log files later on that it now loads drivers in parallel, not one by one after each other. And we also have changes in how many of you have tested redirected folders in XP? A good few of you, most of you. How will that affect login and logout? Not very good. It simply takes some time when it's doing the sync. Now all that sync is happening in the background. It's using delta changes, using enhancements in the protocol so that you don't synchronize that much data either. But simply, you can log on, log out much, much quicker now. Now, if you have a system that behaves badly, users will normally inform you of that situation. And they normally have two ways they explain their frustration to you. If you're lucky, they look like this. At least that's sort of a friendly ask for help. Or they look like this. which is a typical manager running late to a sales meeting, and the machine doesn't boot fast enough for him. Now, in Windows, we have a few inbox tools. We have the Task Manager, we have the Resource Monitor, we have Perfmon, and we have a bunch of almost undocumented switches to Perfmon that allows us to do things that was not possible before. As I told you, Windows 7 has a new platform for performance counters or performance. That's called event tracing for Windows. That's something we can tap into. If you want to write your own scripts and tools, you can do that too, but we will actually download tools and ready-made for troubleshooting performance. Now, if I jump over to my demo machine, and I go to one of my VMs, and just open up Task Manager, for example. It's been around for ages. This is where we can see all our processes, all our applications. We can control the priority level, if we are high real-time or above normal or whatever. I cannot set affinity here. Why can't I set affinity here? Why can't I decide on what CPUs my processes are supposed to run on? Well, quite easy, because this machine only has one CPU and not much to select from. It has to be that one. But if I go to a VM where I have assigned more CPUs, I have assigned 4 CPUs to this one, well, then I can suddenly go to a process and I can determine, I can click and say set affinity, and I can now select what CPUs that processor or process is supposed to run on. This is something you normally have to do if you do application compatibility issues. If you're trying to have important applications like StarCraft 1 to run on Windows 7. It doesn't accept multiple CPUs. Now, in Task Manager, of course, we can start new processes and close them and end them and such. But we can also use Perfmon, that we can start from a command prompt. And I will do that from the right machine. It will actually have a nice green touch to it. So I can start Perfmon, if I can type correctly. And it's opened up the normal performance monitor. And this has been around since NT 3.1, where you can simply add in the features you want to look for. You can add processor information, and you can not click help or click OK. You can see them in a graph. You can see them in a histogram. You can see them in a report. This has been around forever. But what I also can do with Perfmon is I can run a report. So I can add in the /report switch. And now Perfmon will gather system information for 60 seconds about the system. And it's doing a quite extensive search through all the major components in Windows. And then it will give you a report back that allows you to sort of give a quick overview of how the system is doing. Now, while it's doing that, we also have information in the event viewer related to system performance. So if you open up event viewer of a Windows 7 box, and you go into the application logs, Microsoft, Windows, you will have diagnostic, here we go, and performance. This is where you will see all performance related to events. You will see, for example, the last shutdown, the last boot duration, more shutdowns, more boots. But sometimes you see information in here related to, this application caused a delay in the shutdown process. And it will show you that this process was spending about 5 seconds doing what it was doing. Now, this is a VM. No, not many applications. Of course, it's not many errors in here. But if I open up a saved log from a live system, I will have more information. And if I filter here, and only filter to see events of 301 and 302, which are driver events, I will get a listing of how much time, for example, a driver took to either boot or stand by, in this case, a system. So if I go down here to a few, let me see, this one, for example. This I was trying to hibernate a laptop, or rather go into standby, but the video driver, the NVIDIA video driver, actually spent 4 seconds preventing my standby. So if you have a machine that simply takes, you think it takes too long to stand by, go into the event viewer and try to find out what drivers that was preventing that. I was working with another customer. They had a 3-minute delay when they did hibernation, and that's long. When you are on the airport, you just want to shut down the machine and run on board. Well, turns out it was the Huawei broadband thing they were using for that device that were preventing it from shutdown. But without these types of events, it's more or less possible to troubleshoot things like that. Now, going back to my report that is supposed to be finished now. This is the diagnostics report. I have an overview in the top. So if I hover over this one here, I will get a main window where I can see the overview of the report. But then, of course, I can drill down and see, for example, do I have any issues with my disks? Can I see, for example, hot files in my system? Which files are causing the most disk I/O? Again, that could be preventing my machine from doing what it's supposed to do. And you get pretty detailed information here. And additional recommendations and warning. In this case, it complains the system is not rated. Yeah, that's because it's a VM. You cannot rate the VM. But the normal system, you can go to index and you can rate it. And that can also make performance better for graphics drivers. But this is simply a quick check to see if your system is behaving nicely, and if you get an additional warnings, you can view that. You can run perfmon-sys, which will simply kick off it in a standalone mode, and I can start monitoring the CPU, for example, right now. But I can also run it in a sort of new mode called compare. This performance monitor here has 2 menus. It has file and it has help. But if I run it with the comp switch, I have 3 menus. One of them is compare. So now I can actually add in snap to compare. I have 2 windows side by side. And I can set the transparency so I can see the windows on top of each other. So now I can add in, for example, counters from another machine, PC05, 05. So now I have 2 systems running side by side, but I can monitor at the same. This could be useful if you have one system that it's working quite okay, and you have another similar system that is not working quite okay. And then you can simply overlay them on top of each other and see if something stands out that can help you troubleshoot that system. Now, in Windows 7, we also have the resource monitor. And you can either open it up from the start menu, or you can do perfmon, and you can do a switch to open it up as well. It's either way. Same opening the resource monitor. And this is sort of a quick overview of CPU, memory, disk, and what processes are doing what in the system. Especially useful could be network when you're troubleshooting network issues and simply want to know quickly what process is actually doing what on the network. Now, related to this, we also have reliability history in Windows 7. And this is something that has been recorded since the day you deployed the machine. So you can see we can jump back in time here since I deployed this VM. And for every day, you will have a series of events that can help you troubleshoot information. Now, this is a VM, hasn't done much, but if I open up another, from a live system, you can actually see we have much more information. Apparently this day, someone was installing 3D Studio Max. Apparently another day, they were having issues. Windows Media Player failed to work. Windows was not properly shut down. And someone installed an Ethernet media port driver on this system. So here is the deal. This is superior for help desk. If a user complains, my machine is accidentally not behaving very well, this application is crashing, you can ask the user, what did you do? They would respond, nothing. And then you go back into the reliability history and you will see that, well, this stuff that you installed on April 4, you know, that DVD that came with the PC Gamer magazine that you installed every game on your machine? Do you think that could have something to do with it? Yeah, could be. But this could also be that you have an application crashing from time to time, and you get an update from the vendor. You will immediately see if that update is actually making the system better or worse, because you have the history back. You can see before it maybe crashed 7 times a week, now it's only 2 times a week. So you can simply see if it's better. But the only downside, I think, of this is you cannot open up remote system and compare them in this UI. But luckily, these days we have PowerShell. And through PowerShell, we can retrieve the same information as we see here. And yes, then we can compare systems. We can simply run PowerShell remotely and do things, which is pretty cool. Now, then we have the tools that are related to the inbox tools. How many of you have played around with the sysinternals tools? Most of you have. Most of you should. That's good. They have been around for ages. My favorites back in the days was Filemon and Regimon. They saved my life a number of times. They are now being compressed into the Process Monitor, as you probably know. But, for example, the Process Explorer is a great tool to use if you want to troubleshoot processes and see what they are doing. So if I go back to my demo machine, go into the setup folder, sysinternals, and I kick off Process Explorer. This is a much richer way to see processes compared with Task Manager. And if I open up a new process, Notepad, it will appear with the green one here, and if I close it, it will eventually turn red and disappear. By default, this happens very quickly. But what I did in this configuration, I changed the update speed to 5 seconds so that I can clearly see processes come and go. And this can also be useful if you're troubleshooting intermediate issues on the machine. Sometimes, for example, I was troubleshooting perfmon before, or using perfmon. Where did you go, my friend? Am I blind? Here we go, Process Explorer. Here we go. When you look at individual processes, you will see much more detailed information about them. What they're doing on the network, any strings they might have. And that is open up the binaries and looking for strings. Could be useful when trying to find out switches that you don't know beforehand. But you also get performance related to that process alone and the performance information in details. And of course, you can close and delete processes from here as well. Another favorite is the process monitor, which can be useful to identify what applications are doing in my system. So in this case, if you don't specify any filter, Process Monitor will monitor everything that happens. But I've set a filter for Notepad. So if I hit OK, it will now record every event in Windows related to what Notepad does. So if I open up Notepad and do something, changing the font, Verdana, and close it, we will now have a recording of what Notepad did in my system, what it did in my file system, and what it did in my registry. And this can be useful if you're troubleshooting applications that you expect or you think they are hammering the file system apart. You will simply get one line for every file access that application is doing, and you can export this, you can import it into Excel, and you can do one of the top charts to simply see what files that are being hammered. Not so much for clients, but for servers, oh yes. This is where we can see if we would benefit from maybe, say that we have a config manager server for managing our environment. That config manager server is using SQL. SQL is using a database and log files. Many moving parts that is hammering on the drive. By using techniques like this, we can actually see if we would benefit from moving some of the files or some of the folders to maybe another drive, to another array, to get more performance out of the system. So Process Monitor is not only for live analysis, it can also be for long term, because we can set the filters, and we can do even more filters if you don't need to view every type of event. We can just view reads, for example, or writes, so that we can quickly see what the machine is doing. Now, the Performance Toolkit is a kit that allows you to go deeper. This is the kit that's been used internally at Microsoft during the Vista development timeframe, but then was part now of the SDK. It used to be a separate download. Now it's part of the Windows 7.1 SDK. And in the SDK, you will find the Performance Analyzer tool. It's a full suite. It's using the event tracing Windows infrastructure, and this one will allow you to capture things and view them in various analysis tools. Now, there are a bunch of tools in this suite, but these are the 5 most important to an IT pro. The Xperf utility, that's the component you use to start and stop traces. And this is also where you define what you want to trace. Xperf View is used to view the trace, view the result. Xboot Manager is used to start and stop traces during boot, so we can simulate the entire tracing throughout the restart of the machine. We have the Power to ETV. We can convert power management events so that we can view them in the Xperf View. And there is a sim cache-in, which allowing developers, or rather converting debugging information to the sim cache using this generator. I happen to have the Windows 7 SDK mounted, the ISO. If I go into the Setup folder, this is where you will find the Performance Toolkit. And you will see you have one for each architecture. And that's simply an MSI that you run and install on the system. That's no big, it's 20 megs. After you installed it, it will end up in the Program Files Windows Performance Toolkit folder. And this is where you will find, for example, the XPerf tool that I talked about. But if you only want to start and stop a trace, you actually only need 2 files, perf control and xperf. So you want to start a trace on another system, just copy these files and you can run the trace on that. Or if you're lazy, just copy this folder. It's 20 megs in size, it's not that big. You do not have to install it on every machine, it's just an X copy of this folder. Now, if I go to a command prompt and type xperf, you have a bunch of command line switches, of course, but if you type in profiles, you will see a ready-made listing of commonly used traces. So for example, there will be a ready-made profile for doing file I/O tracing. There will be one for common system metrics. There will be one specifically for IE8, etc. And most of these, they have 2 versions of them. So for example, this one will do a general trace, but it will store the result in a file. Is this one useful if I'm troubleshooting issues that I think are related to disk access? Not so bright, maybe. Because now I'm having a big log file being hammered on the same drive that I'm troubleshooting. I would say I would rather use the in buffer. I will store the log file in memory, and when I'm done with my trace, then I will save it. This utility is not for long-term analysis. The log files will be big. You can have tens of thousands of events gathered quite quickly. But the last one, this, is the most useful one. That's the only time you don't use this one if you're troubleshooting memory issues. Then you probably will run into the file, and then you can run it longer because you often have more disk space than you have memory space. So if I type in xperf, and I type in start, and let me actually just copy the profile name here so I don't have to type. So xperf, start, and the profile name. And then I specify, when I save this, a file where I want to store this. But I will start the trace, so it started. So if now I can open up Internet Explorer. If I would have internet access, I would have been able to surf, but I won't do that. So instead, I will kick off Microsoft Paint, and I will do some extreme art in Microsoft Paint. I will go into the, let me see here, demo. Play a movie without sound, exciting. Great reasons to visit Seattle. 2 developers trying to talk us into go to Seattle. They don't do a very good job. And when I've done with my changes, I've done a few things in my system, I can now stop the trace by simply doing the same command, but saying stop and specifying the file name. So I will do stop, and I will output the file name, demo, TechEd02.etl. And it's now saving the output shortly, and I will have my trace. You give a good warning here. This information may contain personally identifiable information. Yep. So before sending this away to someone, please be aware of that. Now I can view start xperf again and simply specify the file name. and it will now open up in XPerf view. You get a good warning. Don't run traces elevated. Would you run it unelevated? Yes, please. And now you get a graph that contains information from that trace. So for example, you can see the CPU movement, you can see all the processes, and of course you can clear them out, select individual processes, but you can also do overlay here. For example, a bit down, we will have disk I/O that was going on during my trace. So I can now overlay. I right-click and say overlay, and I can overlay with disk I/O. So I can now see if specific processes, or CPU access in this case, but if I do it here, I will get processes. So I can see what processes that are hammering my disks the most. I can get some good information about the system information, the current version of Windows, the traces, information about that, storage, display, network information, all my running services, plug-and-play numbers, etc. of my machine. But what I also can do is that I can go to, for example, disk. I can select the section here. I can zoom in to get more details. I can get a summary table. What processes were doing how many reads and writes on my disks. But I can also go to, if I right-click and say detailed graph, I will actually get, it's a bit difficult to see, but this is all the sectors on my drive and what processes that were reading and writing to what sectors. And I mean, this is quite good, because as you can see, most of my processes, they are basically reading and writing on the same spot on the disk. Good. The disk is probably not too defragged. But sometimes you see processes writing all over the disk, giving you a notification, should maybe turn on defrag or buy in solid state drive. Either way. This is where you will see information about the drive, and you can see, for example, if write caching is enabled. Can also be an indicator that something is going slow. If this one is disabled, normally it should be enabled, depending on hardware. And if you hover over a process, you actually will get additional information about this one. So you can quickly see what happens. If you want, you can convert this to a text file, this trace. So if I go back to my command prompt, I can type xperf, and I will do -i for input and -o for output, and I will output this to a TeCO2 CSV text file. And it's now exporting this file into a text file, which you will realize quickly, it's slightly larger than the ETL file. The ETL file is a very, very efficient format to store log information. Because I was doing tracing now for, 30 seconds, 35, maybe up to a minute. But if I go to my demo folder and do a directory listing, you can see that the text file is almost 300 megs in size. Do not open this in Notepad. Notepad will be upset. If you really want to dive into that information, you can simply use the type command and the text file, and you can review the information that way, or through a larger text editor. Word is not good either. You get the point. And this allows you to take the same information and view in any way you want. But for the most part, I would argue and say the performance analyzer, it's the best tool to review this information. Now, The thing that makes this work is the event tracing for Windows, the mechanism, the platform that makes logging possible. I showed you the profiles before, but we also have providers. If you don't like the default tracing profiles, you can create your own. You can specify exactly what component you want to monitor. If you want to monitor BitLocker performance, you can actually enable a provider called, well, Microsoft Windows BitLocker, whatever the name is. And you can use the provider switch for XPerf to see all available providers. And there are hundreds of them. But these providers, you use the buffers, for example, configured by the kernel to start the tracing. All the providers will make sure that only the information that you select will be gathered. You control this entire process through XPerf. This is, again, stop and start in the processes. But you might saw, or you probably saw when I stopped the trace, it was not an immediate stop. It actually took a few good seconds when I run stop. And that is when Windows is adding additional information into the trace. For example, if I'm monitoring network things, network providers, Windows will inject network stack information into the trace that also can help me troubleshoot. And then in the very event, I will use XPerf View to review the information, and I can export to CSV or XML files or whatever to review that information even more. Now, if you want more details about what the event tracing for Windows does, fine. You will find plenty of information on the MSDN website. Now, what I recommend is rather try to use this. So, scenario, you want to troubleshoot why a machine takes so long time to boot. Well, or to log in. Well, in this case, I cannot use XPerf, but I can use Xboot Manager. So I will open up a command prompt again, and instead I will run Xboot Manager to review the same type of information, but during my boot. So I will create a folder, boot TechEd, or TechEd boot. And I will run Xboot Manager, and I will kick in, I will say trace, and I will say boot. And it will now reboot my machine. Not many warnings here. Shutting down for boot trace. And then it shuts down the machine and reboots. Now this was a VM, so my remote desktop connection to it sort of broke. But I should see here it's now being restarting. And eventually it will kick up again and allow me to remotely connect to it. Here we go. And you will see it's now continuing for additional 2 minutes. It's a countdown here going on. This is because, again, Windows lies to you. Just because you could log in doesn't mean everything is done in the background. But I don't want to wait for 2 minutes. I'm simply click Finish, and it will now stop the trace, inject the metadata information, and it will now store the trace in that folder. It's coming. It's coming. Shortly. Done. So now I have a full trace of my entire boot. So if I go to my demo folder, the TechEd boot folder, and I open up this trace, you will now see what the system was doing during that reboot. For example, again, how much it was reading and writing for my disk. The I/O counts, but more importantly, other stuff going on during that time frame. What processes were running? In this case, process lifetimes. But we have even more information here. You can see exactly when different services and components started and stopped. For example, in this case here, Windows Defender started and stopped. You will see plug and play kicking in. You will see other services coming and go. Really useful, for example, to figure out if you have, say, a login script running for a long time. You suspect that you have group policies that is taking a long time. There is a session tomorrow, I don't remember what time, but it's Andreas Stenhall who's giving it, another Swede with a weird accent. But he shows you in that session how you can use the same type of technologies to troubleshoot group policy related events too. So you can dwell into group policy specific things because they are often causing problems at login time or at startup time. Of course, this was a VM. Not so much fun information in here. But still, I can see what's going on. If I rather open up another trace from a live system, which is slightly bigger, like 5 times, you will have much more information, much more processes, much more disk I/O, much more stuff going on. Google Crash Handler kicking in. Guess what? Flash Player Update Service kicking in. AutoStore, which is a backup agent. Things that we don't really see unless we have tools like this. I can go into my processes even more and see that, well, of course, in the middle here, one of the most critical services ever, I play Skyrim. It is a Steam agent, okay? But this is also where you see driver applications kicking in. In this case, apparently group policy was doing something. The HP Health Service kicked in. Windows Update kicked in. Adobe Flush update thing. A Skype update thing. .NET Framework optimizations. I mean, you will clearly see what processes that is taking that long time. As you can see, there are not many things here, because the profile I used to capture didn't include much of the kernel information, because I didn't need to troubleshoot those. But sometimes you need that as well. For example, if this was not only a few seconds here, or up to a minute, I can add additional profiles. Remember, I can kick off xperf, and I can look for providers, and it will be listing for quite a long time. But this is where you can see all the types of providers that you can look for and enable and trace for. Very much information can be gathered through that normal trace. So all in all, most problems that you will see are related to disks. And again, only one broken citizen will impact that behavior of the entire system. The smartest thing I think you guys could do is to actually replace most of the drives that you have. It will give your old machines a brand new life. And for those of you who haven't been to Fry's in the US, you can think of it as IKEA, but for hardware. You don't go to the hardware section, you go to the, no, you don't go to the hard drive section, you go to the hard drive alley. It's an aisle with drivers, with the 6 people that are staffed to work in that area. So it's simply a superior visit if you're a geek. Now, if there is a place to park your wife, depends on if she's a geek as you are or not. But sometimes things are not related to applications running or the system being slow at booting. This scenario is from a machine where sometimes when you were using applications or just moving the mouse, the mouse stuttered. It just stuttered over the screen. And when I got that tray sent to me, I will open up this one actually. Normally, such a thing would indicate that the CPU was being hammered when the machine is doing like that, stuttering when you try to move things around. But as you can see, the CPU usage was clearly not the case. And sure, there were processes, but they weren't doing much. If I look at the I/O counts on the disks, very low all the time. Disk usage, yeah, it's high in the beginning, but then nothing through that trace. Not too many information about processes either. Interrupt CPU usage, 1%, big deal. That's nothing. So there wasn't much information in here that can reveal any information. But if you want to troubleshoot drivers, you need to know that drivers are using something called deferred procedure calls, interrupts to the system. And they have a very, very high priority. The thing is that the driver is supposed to do something with the hardware, hand over that to the system is, yes, thank you, and then it's supposed to return it back again, really quick. Now, we can enable that ribbon. So I just expanded the frame list here on the left, and there is a deferred procedure called CPU usage. And now suddenly we see that, all right, the interrupts were spiking the CPU at all times. If I select the section and go to the summary table here, I could actually see that one specific driver, where the name has been changed to prevent the innocent, but it was created by a mouse driver, created by a company known for intelligent mouses. But you can see that this driver alone was spending too much time compared with every other driver on the system. And in this case, all right, this was during a beta product, during a beta program, fine, got the new driver, the problem went away. But this is how you can find out stuff like that. Without this, impossible. So download these tools, play around with them. Know that they exist and that you can use them to dive deep into all types of stuff that is going on in Windows. How many of you have actually used these tools before? Some of you have, all right. 20% or so. So with that, ladies and gentlemen, I would like to highlight a few other related content. Andrea's session is tomorrow as well. And don't forget, please, to fill in the evals. And as always, be gentle but honest. And thank you for taking your time.